All right, so what we have found in the past is that Unit 7-1 and Unit 7-2 tend to be a little repetitive. So we're going to put them in one video together and just have the one homework assignment on the two. So sometimes when you're working on a percent problem, you won't have a paper and pencil or a calculator available. You can estimate percents by knowing some common fractions and their percent equivalents. Estimating fractions can also help you check whether an answer is reasonable. So there's a lot of fractions where we already know their percent equivalents. Like, for example, 1/2 is 50%. Most people know the third and the 2/3 rules, 33.3 repeating percent and 66.6 repeating percent. The quarters, right? Because we use money, most people know 1/4 and 3/4. The fifths, even if you don't know them, if you think about 100 divided by 5, you get 20 or 20%. And then in order to get the rest of them, you just either add on another 20%, or you can say, oh, well, I want 4/5. So that would be 4 groups of 20% or 80%. So for the most part, the halves, thirds, fourths, and fifths are ones we either already know or we can easily come up with them. When we come to the eighths, and by eighths, you'll notice there are only 4 fractions listed in the eighths. We typically aren't as familiar with the eighths. Well, we do know 2/8, which would be 1/4. We do know 4/8, which would be 1/2. And we do know 6/8, which would be 3/4. So we only have to memorize the other 4, which are the ones with the odd numerators. So every eighth is worth 12.5%. And you're like, well, that's a weird one. It's really not. 1/4 is 25%. Half of that, or 1/8, is 12.5%. So most people need to spend a little bit of time memorizing those. Next are the ninths, and the ninths are great because the ninths are just the numerator repeating. So 1/9 is 11.1 repeating, 2/9 is 22.2 repeating. You'll notice 3/9 is missing. Well, it's missing because we have it somewhere else. The 3/9 that belongs right here is the same as 1/3. And then if you go down the list, 4/9, 5/9, the 6/9 that's missing right here, we've got over here is 2/3. So they're not really missing, they're just not in lowest terms, so they wouldn't be listed with the rest of the ninths. And then we've got the tenths. And for the most part, this is the first percent that people learn because 10 out of 100 is 10%. 30 out of 100, 30%. Well, if you put those in lowest terms, you get 1/10, 3/10, and so on. So if we look at the questions that we've got at the bottom that are sort of asking us to think a little bit deeper, why isn't 3/3 included on the list? Well, 3/3, it's worth 1/2. And so we don't put any of the ones that are worth 1/2 on the list because there's so many of them. 4/4, 5/5, 12/12, 1,000, 1,000. Anytime the numerator and the denominator is the same, it's worth 1/2. So why didn't we put 2/4 in the fourths column? Well, we did sort of touch on that with the eighths and the ninths. 2/4 isn't in lowest terms. So we don't put anything that's not in lowest terms because that means it belongs somewhere else. What other fractions are equivalent to 2/4? Well, we know that 2/4 is worth 1/2. So anything where the numerator is half of the denominator, it's going to be another fraction worth 1/2. So we could do 1,000, 2,000s, and that would work. What do all the thirds and ninths have in common? So if we look back at the thirds and the ninths, you'll notice those ones all have a decimal that repeats. And it also has that same digit. So what do they all have? A single repeating digit. How can you easily remember the ninths? We said at the top it was the numerator repeating. And so in this case, it's just a single digit that repeats. So if your numerator is 2/9, that's where you get the 22.2 repeating percent because it's just the numerator repeating. Now, if you had, say, 15/9, it does not follow that pattern. It only works when you have a single digit numerator. Why are only 2 of the sixths listed? So we didn't talk about the sixths up at the top, and we're going to spend the time doing that now. So you'll notice 1/6 is on the list and 5/6 is on the list, but where's the rest? Well, 2/6 is already somewhere else in our list. It's 1/3. 3/6 is already somewhere on our list. It's 1/2. And 4/6 is already on our list at 2/3. So the other set of numbers that people usually have to spend some time memorizing are the sixths. So really, guys, that means you have 6 fractions where you have to memorize their percent equivalent. Anything that's not currently in a box are ones that you probably should already have by 7th grade. When you want to estimate a percent from a fraction, you can change either the numerator or denominator by 1. So suppose a class of 28 students is surveyed to find what percent of students like the show America's Got Talent. 22 students said they liked the show. Well, that means it's 22 students out of 28 reported that they liked the show. Now, if I put that in lowest terms, I get 11/14, which isn't particularly friendly. 14ths isn't one that we know. But what we can do to find a nice fraction is either increase the 22 to 23, and we're like, no, 23/28, lowest terms, not friendly. We can decrease the numerator by 1. 22 take away 1 is 21/28. Well, that one in lowest terms, it's 3/4, and we know that 3/4 is worth 75%. So we can get a really good estimate. We can say, well, 22/28 isn't exactly 75%, but it's close. Another option is to change your denominator by 1. So we could go 22, which we don't change at all, and then go to 29ths. That's in lowest terms. That's not going to help. Another option would be to bring the 28 down to 27. 22/27. It's in lowest terms. It's not particularly helpful. Being able to change your numerator or denominator by 1 will usually result in a single, sometimes 2, but usually 1 that is friendly, something that we can put in lowest terms and something that we know a reasonable estimate for. So we would say about 75% of those kids surveyed like America's Got Talent. So what if we want to do that with 13/18? We can change one number, either the 13 or the 18, and we can only change it by 1 place. So let's say I were to go up by 1 on the numerator. Let's say I went up to 14/18. I would say, ooh, that's nice. Now they're both even. And that is 7/9. And I know from the front, my ninths would be 77.7 repeating percent. So I can estimate that one. That's great. Another option, if you notice, the 13 could have gone down by 1. And we could have gone to 12 and said it's approximately 12/18. And you might say, oh, 12 and 18 are both divisible by 6. That's 2/3. Another reasonable estimate would be 66.6 repeating percent. And when you're doing these problems, not everyone's going to make the same choice. I would accept both of those. The next one is 9/24. And sometimes the answer isn't always about getting a friendly one to reduce or simplify, I should say. Sometimes it's about getting a fraction that is friendlier to change into a percent, like something that ends with 25ths, because 25ths are really easy to get to 100. So it's not always about getting it to lowest terms. If I add 1 to the denominator here, I've got something with 25ths. I can do times 4, I can do times 4 and get 36/100ths and say, oh, it's about 36%. So that's another option as well. Now, 29/90ths, you may say, oh, I don't know, do I go 89? Do I go 91? Nah, neither of those are really helpful. I might bring the 29 up by 1 and go with 30/90ths, which is 1/3. And we know that that is 33.3 repeating percent. So either one here, really the easiest one to go with here is the 25ths. If you noticed, just for argument's sake, that 9/24 are both divisible by 3, you could go with 3/8. And if you look at the front, or if you've already memorized it, 3/8 is 37.5%. Not a lot of people notice that one, but that one is actually an exact answer. I did not have to add or subtract because 9/24 could already go to lowest terms. So I would say, and anyone who's wondering why I'm going with approximately, because way back here, I changed the value. So my final answer is approximate. Way back here at the beginning, I changed my answer. So I could go with 77.7 repeating percent or 66.6 repeating percent. But you'll notice that that little approximately is there at the front because I had to round the original fraction to something else. Now, Julia estimates 5/24 and she goes to the nice fraction 6/24, right? So she added 1 to her numerator. So the 6/24 is going to be approximately 1/4 if you put it in lowest terms, or 25%. Yvonne used the nice fraction 5/25. So Yvonne actually changed the denominator. 5/25 is 1/5, or approximately 20%. Both girls have done something that's fine. They changed either the numerator or the denominator by 1. If we wanted to, just for the heck of it, see whether Julia or Yvonne had a better or answer that was closer to the exact, we could solve this proportion. 5/24 equals x over 100. 24 times x equals 5 times 100, or 500. Divide both sides by 24 and get that x is 20.83 with the 3 repeating percent. And we would say that Yvonne had the closer estimate. Both girls had acceptable estimates, but it turns out Yvonne's is closer to the actual. Now, at the beginning of this, you heard me say that we are going to do 2 lessons in one video, and hopefully you'll notice that there's a little bit of overlap here, right? So percent fraction equivalence. If you want to pause the video, you can try to sort of quiz yourself here just for the heck of it and see how you do. So on this page, we're saying, here's the percent. Now you give me the fraction. We're trying to do the reverse so we can practice it in both ways. So 25%, 1/4. If I go down 50%, that's your 2/4 or 1/2. 75%, that's your 3/4. 100%, just if we were following the pattern here, would be 4/4. But you could pick any fraction that's worth 1. The 20, 40, 60, 80, 20 goes into 100 exactly 5 times, so it's 1/5. If we double that, 2/5. If we took the original and we tripled it, 3/5. If we went back to the original 20% and we did times 4, it would be 4/5. Down the middle column, notice all of those percents end in 0, so they are all tenths. So 1/10, 3/10, 7/10, and 9/10. So anything where you have a percent that ends in a 0, those are going to be your tenths. Then we have the ones that I told everybody they were going to need to spend some time on. The ones that were 12.5, 37.5, 62.5, 87.5, those were your eighths. So this was 1/8. Remember, 2/8 we did not list with the eighths because it could also be written as a fourth. So we then had 3/8. 62.5 is 5/8, and 87.5 is 7/8. Now, I would reiterate that these are going to be ones that you need to spend some time on, right? You probably don't already have those memorized. Along with 16 and 2/3%, which is 1/6. And down here at the bottom, 83.3 repeating, or 83 1/3% is 5/6. Those are the other ones that people typically have to spend some time on. Now I've got 2 spots left. You will notice 33 1/3, 66 2/3. We often see those with the repeating decimal, and sometimes we recognize that a little faster as 1/3 and 2/3. So quiz yourself on those. Make some flashcards if you need to, because it is an expectation at the end of 7th grade that we do have these sets memorized. Find each percentage using friendly fractions. Now, if we hearken back to the olden days when we learned about multiplication, the word of typically refers to multiplication. So what we're really asking you to do here is 75% times 24. And if you look, 75% is 3/4. So we're asking you to use a friendly fraction. So instead of 75%, instead of the decimal of 75%, instead of a proportion, what is 3/4 of 24? And we can just do times and multiply. Now the 4 and the 24 can simplify, and we would get 18 over 1, or just 18. So not terrible as long as we know our fraction equivalent. So 80%, which is 4/5, and instead of the of, we're going to change it to multiplication, times 60 over 1. So the 5 and the 60 I can simplify. 5 divided by 5 is 1. 60 divided by 5 is 12. So 4 times 12 going to be 48 over 1. What's funny, on my paper, I actually wrote 80% as 8/10 times 60 over 1. and you will notice you are going to get the exact same answer. So if you thought of 80% ends in a 0 and you thought, ooh, it's got to be one of those tenths, that would work too. 30% of 70. So instead of 30%, I'm going to use 3/10 of multiplication. And there's my 70, just writing it as 70 over 1. 10 and 70 both divisible by 10. And 3 times 7 is 21. Now, if you had written 21 over 1, you would then get to 21 as your final answer. 10%, 1/10 of times 76. Notice you can move your decimal point over and say 7.6 if we wanted a decimal, but we're looking for fraction work. So the 76 and the 10, you can simplify them, but I would argue that 76/10 is pretty easy to work with. 7 and 6/10, which is 7 and 3/5. If you wanted to, you could put this in lowest terms and go 38/5, and either one would work. Christine has a 20% off coupon for the Gap. If her purchase's original cost is $110, how much will she save with her coupon? So she's saving 20%, which we said was 1/5 of $110. So I can simplify. If you don't know what it is, you can put 110 over 5 and just do the division. 5 divided by 1 is, 5 divided by 5 is 1. 110 divided by 5 is 22. So it's 22 over 1, or a $22 discount. And just for argument's sake, if it was $110 and they took off 20%, they'd be taking off $22, and you would get a final price of $88. All right, we've done that before, just don't want to forget how to do it. Estimate the following using friendly fractions. So in this case, we're saying 26% was not on our list, but what was a fraction that was pretty close to 26%? So very close to 26 was 25%. So I'm going to use 1/4 times 64 to get a good estimate. So 4 divided by 4 is 1. 64 divided by 4 is 16. So I would get 16 over 1, or just 16 as an estimate. And so I really should keep my little squiggles there. And we can say 16 is, now notice I went with 25% and 26. So 16 is a little lower than the actual. And I can say that because had I gone with 26%, it would have been a little bit higher. So 16 is just a little bit below the actual answer. 2/3 of a percent. Now, guys, I have no idea what 2/3 of a percent of something is. So I'm going to go with 1%. So 1% is 1/100th of, or times 891. So I can't even do anything to simplify that. 891 over 100, or we can go with 8 and 91/100ths. It's not a great estimate just because the 891 isn't very friendly. We could also round that to 900 and say that it's about 9, right? These are all about because I rounded. So if we went with this one, we could say 8 and 91/100ths is a little higher than the actual. On this one, we actually changed both numbers, so we wouldn't want to try to estimate a little higher or a little lower. We would just say it's about 9. 39%, really close to 40%. So I'm going to go with 4/10 or 2/5. And instead of 81, I'm going to go with 80 because I noticed my denominator here was a 5, and I knew that was going to simplify really nice with the 80. So 5 divided by 5 is 1. And 80 divided by 5 is going to be 10, 16. So 2 times 16 going to be 32 over 1, or 32. So we can say, we went with 40%. So 32 is a little, oh, I rounded that one up and I rounded that one down. So let's not go with that. We're going to say it's about 32 because we changed both of our numbers. So we don't want to try to guess whether it's a little high or a little low. It's just about 32. Last but not least, 120%. I'm actually going to look for the 20%, which is 1/5. So I'm going to write 1/5 of times, instead of the 51, I'm going to go with 50. And you're like, well, why'd you do that? Well, 1/5 is the 20%. 50%, 50, I went with 50 instead of 51 because I knew it would simplify nicely with the 5. 5 divided by 5 is 1, and 50 divided by 5 is 10. So I know that 20% is about 10. Well, 100% is about 50, and 20% is about the extra 10. So if I put those together, if I want 120% is about 60. You also, for those of you who are curious, could have gone with 6/5 as your 120% altogether instead of breaking it into 100 and the 20 separately like I did. Last question. Scott ordered 4 pizzas. The cost of the pizzas, $57.96. He wants to tip the delivery person 15%. What's a reasonable amount for the tip? Now, 15%, the closest we can get to that from our list was the, 16 2/3% or 16.6 repeating, which is 1/6 of, nobody is finding 1/6 of $57.96. Just rounded up to $60. So I rounded my percent up just by a little bit. I rounded my price up by a little bit. So this person is still getting a perfectly acceptable tip. 6 divided by 6 is 1. 60 divided by 6 is 10. And so we're going to say it's about 10 or about $10 for the tip. About a $10 tip. And so what is reasonable here, if we're going to leave a $10 tip, we're going to say we need to add $10 onto the total. We might just leave, $70 total. That would be your 60-ish, extra 10. Sure, the person gets a little bit of a higher tip, but it's a whole lot easier to hand over $70 than it is to hand over $67.96. So lots of things going on with percents, and there are some that we need to spend some time memorizing.